Let's take a look at one more example to really get a feel for how to calculate these probabilities. The data in a research study has a standard normal distribution. If you randomly choose a data value from the study, what is the probability that the data value will be less than z equals negative 0.83 or greater than z equals negative 0.57 or between z equals negative 0.94 and z equals 1.25? Okay, so three different probabilities that we have to calculate. So let's start with the first one. We are dealing with a standard normal distribution. And so we want for this to find the probability that a data value will be less than negative 0.83. Okay, and again, I'm using z because that's the letter we use when dealing with the standard normal distribution. Okay, so for number one, we want that probability that z is less than negative 0.83. You always want to draw a picture for these. And I have a very nice picture over here ready to go, so you don't have to suffer through watching me do an untidy drawing. This is what we would get. Okay, I have my horizontal axis here, which because it's a standard normal distribution is a z-axis. We use z instead of x for a standard normal distribution. Negative 0.83 is less than 0, so it's to the left. And then I'm interested in the z values that are smaller than negative 0.83. So I'm shade to the left, and that's why this left portion of this is shaded. The area of that shaded region is going to be equal to the probability that z is less than negative 0.83. Now this is exactly the kind of probability that that p-norm function allows us to calculate. Okay, so we don't have to do anything fancy. We just plug into the p-norm function. So p-norm, and I just say the value I'm interested in is negative 0.83. And it's going to calculate the probability that a randomly chosen value is less than that negative 0.83 in the standard normal distribution. And it is 0.203, about 20%. Okay. 0.2032694. Okay, so that one's fairly straightforward, not too tricky. For number two here, now we want to calculate the probability that the data value will be greater than negative 0.57. This one's different, right? In the last one, we wanted a probability that z was less than a value. Now we want the probability that a z would be greater than a value. This one's going to be a little trickier to calculate because it's a greater than rather than a less than. But as always, we should start by sketching out a picture. So let me get my nice picture here off to the side. We have something like this. So this first bell curve, that represents the probability we are looking for. There's negative 0.57. We're interested in the values that are bigger than negative 0.57. So bigger is to the right. That's why the right region here is shaded. The big problem here, of course, is that the p-norm function in the calculator will not give me the probability to the right of negative 0.57 automatically. By default, it gives me the probability to the left. Okay, that's not the probability I want. So if I stick that in here, p norm q equals negative 0.57, that's not going to give me the right answer in this case. It gives me 0.284. That's the area of this region here. Okay, that's not what I want. I want the area over here. So I have to use some cleverness when I have a greater than symbol to be able to calculate the probability. Rather than calculating the probability directly, what I do is I start with the total area under the curve. Because this is the probability density function, if I look at all the area under the curve, that's 1, right? 100%. And then what I do is I subtract out just the part that I don't want. Rather than directly calculating what I do want, I take away what I don't want. I don't want once I have everything that's under the curve, I want the bit that's over here, right, to the right of negative 0.57. So I'm going to take away what's over here to the left of negative 0.57. Okay, so that's what I do here. I'm taking that away. Now this is the probability I could calculate using that p-norm function. Okay, and so what that looks like here is instead of just p-norm, q equals negative 0.57, I have 1 minus p-norm, q equals negative 0.57. And now that will give me the probability I want, which is 0.715, about 72%. So there's about a 72% chance that a randomly chosen data value would be over here. Okay? This is the approach we always take when we are calculating the probability involving a greater than symbol like this. Okay? Rather than calculate the probability directly, it's 1 minus the probability that z is less than that value. Okay? So this was 0.7156612. Okay, one more to go. For number 3, we want the probability that the randomly chosen data value will be between negative 0.94 and 1.25. Mathematically, that looks like we want the probability that a z value is between negative 0.94 and 1.25. Okay? Again, this is not a probability that we could directly calculate using the p-norm function, right? That p-norm function allows us to calculate the probability when just z is less than a value. Here it's not just that z is less than 1.25, but it's also bigger than negative 0.94. It's between the two values. So that makes this a little tricky. So as always, it's a good idea to draw out what you're dealing with. So let me get my nice picture off to the side. Okay, this is a picture of what we want. Again, notice it's not just what's left of 1.25, right? It's what's in between these two values. So we can't directly use the p-norm function in the calculator. Instead, what we're going to do is we're going to start with that bigger value. And we're going to calculate too much. We're going to calculate everything to the left of that bigger value. Okay, so that's what we do. That's what we do here. We calculate everything to the left of that bigger value. Okay, now that's too much, right? We did want the bit that's in between 0.94 and 1.25. We did want this bit right here, but we don't want this bit over here. So just like before, what we're going to do is we're going to subtract out the bit that we don't want. We don't want what's left of negative 0.94. And so that's what we subtract out here. We're subtracting out the extra that we don't want, which is to the left of negative 0.94. It's always going to be, whenever you're calculating the probability between two numbers, it's always the probability to the left of the larger value minus the probability to the left of the smaller value. That makes sure you stay in between those two numbers. Okay? So for this, that will be p norm q equals the bigger value. So that calculates the probability to the left of 1.25. But then I want to subtract out anything that's to the left of the smaller value. I don't want anything that's left of 0.94. And that's 0.72074414. Okay? .72074414. So we've learned how to calculate probability in 3 different circumstances. We've learned how to calculate the probability when it's just left of a value. Okay, this gives us the probability of a normal distribution left of this value. This is the probability. This is what we need to do to calculate the probability in a standard normal distribution to the right of a value. Okay, we take the whole thing and then we subtract out what we don't want. And if we want the probability of a standard normal distribution in between two values, this is the approach we take. We start by calculating the probability to the left of the larger of the two values, and then subtract the probability to the left of the smaller of the two values.